Hi guys, this is Fanindra from Bennett University. In this video, you will learn the following things. What is closed property? Closure properties of contextual language. Let's begin. What is closed property? Contextual language is closed under a particular property if the resultant language obtained after performing the operation on two contextual languages is also a contextual language. For example, let's consider two natural numbers 3 and 5. We will get 0.6 by dividing 3 with 5. Since 0.6 is not a natural number, therefore natural numbers are not closed under division. We will use the same method to prove the closure properties of contextual language. Let's revise some basic elements of context-free grammar. Context-free grammar is the generator of context-free language. Context-free grammar is represented by four tuples as G equal to V, sigma, S and P, where V represents the set of non-terminal symbols, sigma represents set of terminal symbols, and S represents start symbol, and finally P represents the production rule. Now let's see some of the closure properties of context-free language. Context-free language is closed under union, concatenation, and clean star. Context-free language is not closed under intersection and complementation. Now let's see those proofs. Union. Let L1 be a contextual language generated by grammar G1, where G1 equal to V1, sigma, S1 and P1, and let L2 be a contextual language generated by grammar G2, where G2 is denoted as V2, sigma, S2 and P2. Let L be the language obtained by union of L1 and L2, and G is denoted as V, sigma, S and P be the grammar of L. Here you can see L equal to L1 union L2, which is implemented as G equal to G1 union G2. Now the language L will contain non-terminal symbols of L1 and L2. Since there will be a start symbol for the newly formed grammar V equal to V1 union V2 union S. Since the grammar G must contain the rules of G1 and G2, we need to write a new rule consisting rules of G1 and G2, that is S implies S1 union S2, which finally implies P equal to P1 union P2 union S implies S1 union S2. Therefore, finally G equal to V1 union V2 union S and sigma and starting symbol S, and P1 union P2 union S implies S1 union S2. Let's see an example. Let L1 be A power n and B power n, whereas n greater than or equal to 0, and L2 be C power m and D power n, whereas m is greater than or equal to 0. Let L be the union of L1 and L2. Therefore, L equal to A power n, B power n union C power m and D power m, whereas n and m are greater than or equal to 0 is also a contextual language. Now we will see proof for concatenation. The proof is same as before one, but with a slight change. Let L1 be the context-free language generated by G1, and let L2 be a context-free language generated by L2. Let L be the language obtained by concatenation of L1 and L2. Now we can see there is no change in V, but there is slightly a change in P, whereas P equal to P1 union P2 union S implies S1 and S2, but for union it is S1 union S2. Therefore, G equal to V1 union V2 union S and sigma and starting symbol S, and production rule is P1 union P2 union S implies S1 into S2. Let's see an example. Let L1 be a power n and b power n, whereas n greater than or equal to 0, and L2 be c power m into d power m, whereas m is greater than or equal to 0. Let L be the concatenation of L1 and L2. Therefore, L equal to a power n b power n into c power m into d power n, whereas n and m are greater than or equal to 0, is also a context-free language. Now we will see the proof of clean star. Let L1 be a context-free language generated by G1. Clean star is obtained by concatenation of the same symbol multiple times. Let L1 is let L is L1 star. It implies G equal to G1 star. We have where V is equal to V1 union S, and production rule P1 is P1 union S implies S1 into S slash epsilon, where it can be also known as recursive function type. Therefore, G equal to V1 union S sigma and starting symbol S. Production rule is P1 union S implies epsilon slash S1 into S. Let's see an example. Let L1 be a power n into b power n, whereas n is greater than or equal to 0. Let L be clean star of L1. Therefore, L1 star is equal to a power n into b power n, whereas n is greater than or equal to closure, is also a context-free language. Now we will see intersection. There, let L1 be a power n and b power n into c power n, where n and m are greater than or equal to 0, and L2 equal to a power m, b power n and c power n, where n and m are greater than or equal to 0. L1 represents a language where number of A's is equal to number of B's, and L2 represents a language where number of B's is equal to number of C's. Therefore, the intersection of languages L1 and L2 represent a language where number of A's is equal to number of B's and is equal to number of C's. Therefore, L1 is L1 intersection L2 equal to a power n into b power n into c power n, where n is greater than or equal to 0, is not a context-free language. Therefore, context-free language is not closed under intersection. We will see the proof for complementation. Let L1 and L2 be context-free languages. We prove this by proof of contradiction. Let us assume context-free language is closed under complementation. By using De Morgan's law of Boolean algebra, L1 intersection L2 is L1 complement union L2 complement whole complement. But since context-free language is closed under union and complementation, it implies context-free language is also closed under intersection. But before we have proved that context-free language is not closed under intersection. Therefore, by proof of contradiction, context-free language is not closed under complementation. Thank you.